Hello, sixth graders. Today we're working with persuasive data and graphs. Let's take a look here, what we mean by this. This graph right here is really interesting, okay? It shows a favorite food. It says 2,914 people voted. Graph 1 shows 3 sets of data. The yellow line says 972 had pizza. The red line says 987 had hot dogs. The green line says 955 has had hamburgers. The same thing shows that in graph 2. 972 pizza, 987 for hot dogs, 955 for hamburgers. But how come graph 1 you can tell that hot dogs was a favorite compared to graph 2 where it seems like there wasn't much of a difference? The big reason here is on graph 1, the y-axis starts at 950 and it goes up by fives. So there's a big difference between the results between 970 and 975 and 980, 955. So you can really tell there's a big gap between 972 and 987 and 955. But on graph 2, it counts by hundreds. So on something that counts up by that high, you're not going to be able to notice a huge difference with the results. So if you're trying to get a graph that shows something, especially in science, you're going to really have to make sure you change your y-axis to make sure that your graph tells the story that you want it to show. Here's a line graph. Take a look at this example. Graph A and graph B is cell phone use. So in the year 2000, it looks like people, I can't really read that really close, with a cell phone maybe, 4. Must be in millions. Oh, it says millions right there. 4 million people in 2000 had cell phones. In 2005, it looks like 8 million. And in 2010, it looks like 14 million people have cell phones. Well, the same numbers are on graph B, but the line's not as straight up or as a diagonal. It's more of a straight line across. Now, the reason for that is this. It's the same thing with the y-axis. In graph A, where you actually can tell the difference between each year, or over the years to cell phone use, is because the graph counts up by twos on the y-axis. Where on the graph B, it only counts up by, or counts up by tens. So the reason for that is right here, all these results are right around the 10. So it's a straight line. But when you're counting by twos, it actually shows a bigger difference. So I would say graph A is better in this situation. Taking a look here, once again, so it says preferred donut. Brand X or Joe's. Brand X or Joe's. So we have two graphs that have the same data because brand X right here looks like 25. And over here, brand X is 25. Same thing with Joe's is 30. Joe's is 30 here. But this one really shows the difference. The reason why on the first graph here, it says it's because the y-axis is counting up by twos. Or on the preferred donut on the other one, it's counting by fives. So you really see the difference when counting by twos. It's more detailed. Take a look at this graph. The mayor of River City is trying to convince the city council that the city needs more schools. She claims that the city's population doubled since 1998. So doubled, times 2. The mayor used the graph below to support her claim. So if it's doubled since 1998, let's take a look here. 1998, it's probably right around 157,000. Then in 1999, it goes up to 162,000. 2000, it goes to 165,000. 2001, about 172,000. 2002, 180,000. 2003 is at 186,000. 2004 is at 187,000 maybe. And 2005 all the way up at 190,000. This doesn't really show a double. I think it's kind of misleading. It did grow a lot, that's true. But I would have to have this chart over 300,000 for me to show that it doubled because that'd be times 2, right? If you have 100,000 people, if it doubled, you'd have 200,000 people. So I would say this is misleading. It does show a huge increase though, that is for sure. According to the graph, what is the population in 2000? In 2000, the population would be right here, 165, but it's 165,000. Which 2 years was the increase in population the least, so the smallest? Well, this is from year to year, right? So from 1998 to 2000, it looks like it probably increased about 7,000. But over here at the end, it looks like right here is about 186 to 90. So this is about 4,000. That's less than this. And all of these look like they're increasing way too much for the least amount. So I would say from the year 2003 to the year 2005 is the least amount of increase. Now we're doing some multiplication. When you're multiplying by 100 with a decimal, you just count how many zeros it has. Here's a little trick for you. 0.05 times 100. Well, if there's 2 zeros here, you can move this decimal 2 zeros to the right. 1, 2. So the answer is 5. 100 times 5 cents. If you have 5 cents times 100, you would have 100 of them. So yeah, $5. Take a look here. Same thing here. Move the decimal 2 spots. Oh, my bad. Move the decimal 2 spots. So you would have, did I do that last one right? Was that 5 cents or 50 cents? Oh, that was 5 cents. So this would be 2 spots. So this would be 90. 139.25 times 100. You move it 2 spots. So you'd have 13,925. Take a look here. $8.90, but I need to find out what number times 100 would get me there. So you're working backwards on this one, so then you'd have to move the decimal 2 spots this way. Watch close. If I move the decimal 2 spots this way, so then my problem looks like this, 0.089. Now let's check our math just to see if I did this correctly. So I'm going to go ahead and use my calculator at the bottom of the page. So if I go 0.089 times 100, I get 0.9, 8.9. How about right here? If I do 139 and 25 cents times 100, I get 13,925. Right here, I would get 0.90 times 100 equals 90. And then this one would be 5. Hopefully this helped out. You're going to see a lot of these different types of problems in your math today. You can always refer back to the video, but always take a close look with these graphs, what the y-axis is trying to read. Good luck with your math today.